There are many different types of the graph in the data structure, but in this video we're gonna cover all of these different types of the graph in data structures. Graph is always represented by pair of vertex and edges. If your graph is having finite number of vertex and finite number of edges, means the count of vertex and edge is known, then that graph is called as a finite graph. Now here graph is having 4 vertex and 3 edges, so this is finite, and in this graph I am not knowing exactly how many vertices I am having and how many edges I am having. So this will be called as not finite graph or infinite graph. If in your graph number of vertex or number of edges is unknown, then that graph is called as an infinite graph. Trivial graph. If your graph is just having only one vertex without any edge, then that graph is called as a trivial graph. Here there exists zero edge or no edge in the graph, but only one vertex. What if I say that I am having another kind of graph in which there exists no edge or zero edge, but the vertex count is more than 1? Then such graph is called as null graph. The modified version of trivial graph where there is no edges present in the graph but more than one vertex is present, then that graph is called as a null graph. The order of the graph is n, how many vertex you are having in the graph, and the size of the graph will always be 0 in the null graph. In this example, I am having no edge and total 4 vertex are there, so this is a null graph. But if I will say that I am just having 3 edges and 4 vertex, as there exist more than 0 edges, so this will not be a null graph. Directed graph or digraph. If a graph is having edge with some direction, either incoming or outgoing, then that graph will be called as a digraph or directed graph. More commonly, they are represented by this less than or greater than symbol. This represent edge which is going from U and meeting to V. In this example, we are having a graph in which for each and every edges there is a direction. This graph is called as a directed graph. And in G9 graph, we are having no edge or we are having all the edges without any direction, so this is not a directed graph. The graph which is not a directed graph, simply it is called as an undirected graph. In undirected graph, both the edges, that is u comma v or v comma u, are represented by a single edge. For example, here on each edge I am having no direction, so this is called as an undirected graph. What if on your edges, whether you are having edge direction or not, but you are having some labels, you are having some names, values or anything, then that edge will be then such a kind of graph will be called as a labeled graph. Here I am having directed graph with labeling on the edge. Here I am having undirected graph with labeling on the edge, and here I am having undirected graph with labeling on the edge as some number. Instead of writing some names or data, I am having number on the edges. So if you are having such kind of graph where instead of name or anything you are having numbers or values on the edge, then that graph is called as weighted graph. Weighted graph is one of the type of your labeled graph where a graph in which vertices and edges are labeled with weights or numbers. These are the examples of your weighted graph. More commonly we use this weighted graph in the calculation of Dijkstra's algorithm in many different particular applications of the graph. If your graph is having no self loop and no parallel edges, then that is called as a simple graph. Self loop is a edge which is going from the same vertex and coming back to the same vertex without traveling any other vertex. Means on the same vertex there exists a edge going and coming to the same vertex, that is called as a self loop. And the edge which is present between the two vertex, such kind of more than edges are present between the same two vertex, they are called as a parallel edges. Now E1 and E2 is parallel edge because they are present between the two vertex UV. No intermediate vertex is present in between these two vertices, so these are called as a parallel edges. If in a graph you are not having any kind of self loop or parallel edge, then that is called as a simple graph. Now here I am not having any self loop. Again in between any two vertex I am just having single edge, no parallel edge, no multiple lines or no multiple edges. So this graph is not having any parallel edge. As this graph is not having any self loop and no parallel edge, this graph is simple graph. Based on this concept, we are having handshaking lemma. If your graph is not having any self loop nor any parallel edges, then summation of degree of all of your vertex is 2 into edges. Every finite undirected graph has an even number of vertices with odd degree. And the theorem for handshaking lemma is the sum of degree of vertices of a graph is twice the number of edges. Let's take example. These are the two kind of statements for related to that handshaking lemma. So here summation of degree of all the vertex. So degree of A is 3, degree of F is 1, degree of B is 2, degree of C is 2, degree of D is 2 and degree of E is 2. Let's perform addition of all of this. We will get the result as 12. And how many edges we are having? We are having 1, 2, 3, 4, 5, 6. 6 different edges. So just to perform operation of 2 into edge, that will become 2 into 6. There are 6 different edges are available. So we will get on the RHS part, that will be 12. As your LHS and RHS part of this thing is equal, so we say that this satisfies the handshaking lemma. This is my simple graph. Based on this simple graph, we are again having another sentence, that is every finite undirected graph has an even number of vertices with odd degree. The meaning is that you will always get, if in your graph you are having some vertex whose degree is odd. Now here we will check how many vertices we are having whose degree is odd. So we are having F whose degree is 1. I am having vertex A whose degree is 3. Now related to with vertex B, C, D, E, their degree is 2 and number 2 is not an odd number. So I am just having these two vertex whose degree is odd. Now the count of this vertex whose degree is odd is 1 and 2, just 2. So the 2 count of the vertex means 2 is even number. This states that even number of vertices you will have in the graph whose degree is odd. This is the simple graph, and degree of any vertex in the simple graph with n vertex will be at most n minus 1. And maximum number of edges in the simple graph for n vertices will be n into n minus 1 divided by 2. We have just learned what is simple graph. Simple graph is a graph in which there doesn't exist any self loop and there doesn't exist any parallel edges. What if I say for some of the graphs this parallel edges will be allowed? So if I will say you can't have any self loop but you will have parallel edges in your graph, then such graph will be called as multi-graph. This is the example of multi-graph where in between vertex A and D I am having more than one edges, edge E1, E2, whose source and destination is the same, and in between they are not meeting to any particular vertex. These edges are parallel to each other. So E1 edge and E2 edge are parallel edges. In the same way, we don't have any edge parallel edge in the graph. So these two just are the parallel edges whose source and destination is same. This graph is called as a multigraph. What if I say along with parallel edges you can also have self loop in your graph? Then such a graph is called as a pseudo graph. Now in this graph, if I will just add any self loop, I will get the resulting graph as a pseudo graph, a symmetric digraph. If in your directed graph you are having a graph that has self loops and only one directed edges between each pair of vertices, then that graph is called as a asymmetric graph. Now if you will carefully look that in this graph I am having a self loop, okay, as per definition this is okay. Now for all other remaining vertex I should have only one edge between the two vertex, either that should be incoming edge or an outgoing edge. Now in the vertex AB I am having edge which is going in only one direction. In B vertex BC I am having only one directional edge. Again with AC I am having only one directional edge. So this whole graph will be a symmetric graph. Now for this example, in this graph I am having no self loop. Okay, that doesn't matter, but along with that I should not have any parallel edges in the graph. So as there exist two direction of edges in between the two pair of vertex, in between a pair of vertex, so this graph will not be an asymmetric graph. Symmetric digraph. If a graph that has for each and every edge pair there exists its reverse edge, then that graph is called as a symmetric digraph. For each and every pair of vertex you should have to both directional edges, then that graph will be symmetric. Now for example in this graph for the vertex pair x comma y I am not having another directional edge. I should have this edge, then that my graph will be symmetric. But this edge is not present, so this graph will not be my symmetric graph. Now in this graph for each and every vertex pair I am having all the directional edges, so this graph will be symmetric graph. Connected graph and disconnected graph. If from every vertex you can go and reach to any other vertex in the graph, then that graph will be called as a connected graph. Now for example, from vertex A I can meet to vertex B, I can go to vertex A, I can go to vertex D, I can go to vertex C by using this path, then this graph is connected graph. Now another graph where you cannot reach from particular vertex to every other vertex in your graph, then that graph will be called as a disconnected graph. Now for example, from vertex A I can go to B, from vertex A I can go to E, from vertex A I am having a path which is going to D, but from vertex A I am not having any path which is going to C. There is no edge through which in between any vertex through which I can go. I can start from A and I can reach to C. So this graph will be disconnected graph. Because there is no edge or no path present between any particular vertex to all other remaining vertex, then that graph will become disconnected graph. Path matrix will have whether you are having path between the two vertex or not, then that entry will be 1. In a case from each and every vertex you are having path which is going to all other vertex, then that graph will be strongly connected. For example, from vertex A I can come back to vertex A, I am having a path, then that matrix entry will be 1. From vertex A I can go to B, from vertex A I can go to C, from vertex B I can go to B, C, A. All your matrix entries are 1 for the path matrix. If for all the pairs of vertex you are having a path between the two vertex, then that graph will be called as a strongly connected graph. all the path matrix entries will be 1 in this case. Another case is that unilaterally connected. Your graph is unilaterally connected. If you are having for a pair of vertex, you are having just one path which is going in only one directional way. That also a graph is said to be unilaterally connected if it contains a directed path from U to V or a directed path from V to U for every pair of vertex UV. What is the meaning of that? For example, in this graph, I am having path which is going from A to B and which is going from A to C. Now again from B I can go to C but cannot be go to A. So this is just the path. These are all the paths I am having in this graph. So if we will carefully look, then we are getting the graph which is upper triangular graph. If your path matrix for the given connected graph is either upper triangular matrix or lower triangular matrix, then your graph will be unilaterally connected graph. And path matrix values are all the random values, then that graph is called as a weakly connected graph. Now in this case, what we are having a triangular form for our graph, that all the edges are going in only one direction. All the paths is present in sequence of all this vertex. This is unilaterally connected. And now here the direction of edge is very different. Now they are not having any fixed direction, and when we will draw the path matrix, then we will get random paths. There will be a path from A to B, there will be path from C to B. So means I'm not having any upper triangular or lower triangular matrix representation of path for this graph. So this graph will be weakly connected graph. Cycle graph. A graph consists of single cycle in which all vertices of graph are connected, then that graph is called as a cycle graph. Now for example, if I am having 5 vertex and all the 5 vertices are connected, they are forming a cycle whose degree is 2, then that is called as a cycle graph. Now more importantly, in your cycle graph, degree of each and every vertex is 2 for your undirected graph. Again here the cycle graph is having 4 vertex, all they are connected in a cycle C4 graph. Cycle graph is represented by C to the base n, where n is number of vertex in the cycle graph. Now for the 6 vertex in the cycle graph, I will have C6 graph as this graph. There will be no C1 or C2 graph, cycle graph with only one vertex, because if you are just having one vertex, you cannot be able to perform a cycle. If you are just having 2 vertex, you will just get an edge, but it will not be a cycle. In this case, we will say that there will be no cyclic graph for the C1 and C2. Again, for this kind of graph, you should have the parallel edges, but parallel edge is not present in the cycle graph, so you will always get the cycle graph for 3 or more vertices. Star graph. A graph in which you are getting star shaped graph, or a graph which consists of n vertex or n nodes, in which there is only single vertex whose degree is n minus 1 and all other vertices having degree as 1, then such a graph is called as a star graph. Star graph a star graph is represented by symbol s to the base n, where n is number of vertex. Star graph for one vertex is this. Now for example, here I am just having one vertex, I should satisfy this definition. The degree of for n vertex, you should have degree of one vertex as n minus 1 and degree of all other vertex as 1. So the degree of this vertex, as I am just having one vertex, so degree of this will be 1 minus 1, that is 0, no edge is incoming, and all other vertex degree should be 1. But as there is no vertex, so this is satisfying the star graph definition. Now this is the star graph for 3 vertex. This is the star graph for 6 vertex. Now in star graph of 6 vertex, you will have one vertex whose degree is 5 and all 5 vertex will have degree as 1. Wheel graph. Wheel graph is represented by symbol W to the base n. A graph in which you are having cycle graph of n-1 vertex, and there will be one vertex which is connected to all the vertex of your cycle graph. Then such a graph is called as a wheel graph. Now for this example, we are having a cycle graph of 1, 2, 3, 4, 5 vertex cycle graph. This graph is 4 vertex cycle graph. This graph is 6 vertex cycle graph. Now what if I will just add a new vertex which is connected to each and every vertex in your graph. Then such a graph will be called as your wheel graph. I have just introduced one vertex which is connected to each and every other vertex. Then this graph will become a wheel graph. Now for C5, for a cycle graph for 5 vertex, if I will just introduce one new vertex which is connected to all elements of your C5 cycle graph whose length is 5 vertex, then we will get total 6 vertex, and this will be a wheel graph. So this will be a wheel graph of 6 vertex. So this is also a wheel graph where total number of vertex is 7. Complete graph. A graph in which there exists an edge from one vertex to all other vertex, then that graph is called as a complete graph. For example, in this graph I am having 4 vertex. Every vertex is connected to each and every other vertex in the graph. This graph is called as a complete graph. Complete graph is represented by the symbol k to the base n. Now this is 4 vertex complete graph. This will be represented by k to the base 4. This graph is 2 vertex complete graph. This will be represented by k to the base 2. This is k3 graph. Total number of edges in the complete graph is n into n-1 divided by 2. Regular graph. And regular graph is a graph in which degree of your vertex is n. Then that graph is called as a regular graph. Every complete graph is a regular graph, but every regular graph may not be a complete graph. For example, 0 regular graph. Degree of every vertex should be 0. 1 regular graph. In this graph, degree of every vertex should be 1. 2 regular graph. Degree of each and every vertex should be 2. This is a 3 regular graph. Degree of each and every vertex is 3. Bipartite graph. Bipartite graph is also called as a bigraph or bicolorable graph. A graph which can be partitioned into two different sets V1 and V2 such that in between these two sets there is no vertex is present. Let's understand what is that meaning. So if you are having this graph, we should be able to perform a section of this graph into two graphs such that if I will try to let's understand this. If I will make a cut over here, so after cutting all the edges, I will get the two section of the graphs. In that section, when you will remove all of these edges, what you will get? You will get this two portion. This portion is having some set of vertex, and this portion is having some set of vertex. Now what I want after deletion of these edges which are present in between this portion, you should have set of vertex in which there is no edge present between this same set. Now this will be my vertex V1 and this will be my vertex V2 set. Now in all of these vertices I am not having any edge which is present in this all of these elements. Again for this I am not having any edge which is present in between C to D or C to E or any particular vertex. Then this is called as a bipartite graph. Complete bipartite graph. A complete bipartite graph is a graph where from every vertex set V1 we are having edge which is mating to all other vertex in the set V2. And it is represented by symbol k to the base m comma n. For example, this is K23 vertex K23 graph. Now the meaning of this is that this is complete bipartite graph where two vertices are present in the topmost position and three vertices are present in the bottom position. Now we will just draw two vertices and the three vertices at the bottom position. We have to make sure that from each of these vertex set, this is my vertex set V1 and this is my vertex set V2. We should connect all of these vertex to all other vertex set. So this is connected with CDE. This is connected with CDE, but we have not connected these vertices to the same set. This should not be there. So this will be my graph. This is my complete bipartite graph. So the total number of edges in this is m into n. So here total number of edges are 1, 2, 3, 4, 5, 6. For 2, 3, K2, 3, total number of edges is 2 into 3, that is 6. So we are having 6 edges and total number of vertices m plus n, that will be 2 plus 3, that is 5. Complete bipartite graph of a special type where we are having K1, 4 graph, or we will just simply say that we are getting a shape of y. This can be represented as is this graph. So this is called as a claw graph or K1, 4 or a y graph. Some other different types of graph in the data structure are banana tree. In the banana tree is represented by b to the base m comma n, where n represent that what is the star graph, what is the size of your star graph, and m is how many of this star graph you will have in your all of this banana tree, and there will be one additional vertex which is connecting to all of this star graph. So for example, I am having banana tree with 3, 4. So this meaning of this is that I am having 4 this 4 means that I will have 4 star vertex. And how many such 4 star vertex are there? There are 3 such vertex are there. So I need to draw 4 star vertex 3 times, and after completion of this 4 star vertex for the 3 time, I need to connect all of this 4 star graph with just taking one point of that and combine that into some other additional vertex. This will be my banana tree. Firecracker graph. Firecracker graph is another kind of your star graph where it is represented by f to the base m comma n, where n is your star graph. Instead of taking one additional node, now here what we did, we have taken one additional node to connect all of these stars. What if we are just connecting all of these vertexes by using some common edge? So then that will be called as your firecracker graph. Now for the same graph banana tree, if I am just taking one additional vertex, then this will become banana tree. But if I am not taking any additional vertex, I am just trying to make a connection of all of this star graph with each other by using just one edge, then that will be called as a firecracker graph. Kylie tree. An Kylie tree is a graph with each internal node has n branches. Now in this graph, 3 Kylie tree examples are so many, but some of them is that now this internal node should have 3 branches. Now this is having 3 branch. Every internal node should have 3 branch. This is again having 3 branch, 3 branch and 3 branch. The same with this.